Hello and welcome to another episode of Things on Thursdays, where we look at Redis stuff and IoT things. And this is going to be kind of the last regular scheduled Things on Thursdays, which is slightly unusual because we're starting a new project. It's going to be a multi-week project, and it is going to continue here on the live streams, but I'm not going to be able to keep to the Thursday schedule at this time slot. So what we're going to do is this will be our last Thursday 10:30 one for a little while, and then we're going to do sort of ad hoc stuff. So the best thing to do if you want to follow this project would be to continue to check our schedule. So you can find that on the Redis developer page down here. Or if you prefer, you can just go straight to Twitch, which is twitch.tv Redising. Or if you like things on YouTube where they last a bit longer, you can go to youtube.com/Redising and find us there. So what are we going to do today? We're going to pick up on something that my colleague Guy Royce and a couple of others of us have played around with in the past. Guy's done some live streams on this and also developed a conference talk. And what that is we are going to basically read data from aircraft passing by. So this is going to be sort of live demo. I can only see whatever aircraft are passing by that my radio system can reach. I'm going to use a software-defined radio, and we're going to pull data down. Well, we're going to receive that data from the aircraft. They're broadcasting it. And we're going to store it in Redis and do something with it. And what Guy was doing before was storing that data in a Redis stream, so sort of append-only log of when the thing happened and what the thing was. And then he was sort of storing some metadata about those flights and plotting them on a map and sending them to a front end so that you got a map of like local flights, and you could, I think, like hover or click over them and see some more about the flights. What I want to do is slightly different. So for a while, I've wanted to have this thing that looks for flights that are passing by, see what we can see on the radio, and stores information about them. And we'll see what sort of information we get about them. It's kind of basic stuff. But I wanted to get more information about the flight. So I wanted to find out sort of what sort of aircraft it was and the tail number, the registration number, and so on. So we can see, like, rather than just flight number 1234 is passing by the house, we can see that that's like a Boeing 757 and it's DHL and it's delivering parcels to our local airport or something. So what I want to do is combine the information that the radio gives us with information from FlightAware's API. So FlightAware is a service for tracking flights, and they have an API, and you can basically subscribe to that. It is a paid API, but you do get so many free calls a day. And I want to use that information to sort of augment information that we get from the radio. And then this is, after all, an IoT type show. So I don't want to build a web front end. I don't want to bring this up on my laptop and see it. I want a device that sits in the house and just sort of pings or shows us whenever something interesting is going by. And I want to define what interesting is. So I want a set of maybe aircraft types or airline codes or something that, if 747 goes by, we're kind of interested in that. If 737 goes by, we're not interested in that. That happens like 1,000 times a day because they're really common. So I want to build something that's more a sort of single purpose device that's powered by all of this information from the radio. And to do that, it is, after all, a Redis show. So to do that, what we're going to do is use Redis as the data store for storing our flight information. We are going to use it as a queue or a buffer for putting in requests to that FlightAware API. So we can basically have a good split of purpose. We want a component that pulls things from the radio. And then we want a component that looks at that flight number and goes and gets the information from FlightAware if we haven't recently done that. So we have some element of caching. which obviously Redis is very good for. And that will also save us some costs on that flight aware API because we get charged per call after a certain amount per day. And there's also a rate limit that we might have to deal with. And then I want to have something that notifies a device that says, hey, there's an interesting flight come past. Once we've got that information, show it on your screen. So quite a lot to take in there. So what I'm going to do first is run through some of the components that we'll be using and kind of why they're interesting. So the obvious place to start is with the radio. So we've got to pull this data out from somewhere. Aircraft do publish something called ADSB messages as they fly along. It sort of just transmits, and we can listen to those. But we need hardware and stuff to do that. So let's just bring the desktop up. So what we've got is we've got some hardware that works with some software. This software is called dump1090. It's a program that's written in C, and it basically decodes messages that a software-defined radio can receive from the aircraft, and it puts them out into a format on a port that we can listen to and kind of subscribe to. And what we're going to do is do that. This also has an interface so that you can see what is going on. So we can look at these on a map without even building any software. And check that out in a moment. There's a couple of interesting things about this. This was written by a guy on the internet called Antares, or Salvatore Sanfilippo. Salvatore Sanfilippo also created Redis. So these two things don't have to work together. There's nothing in here that's a Redis dependency, but it's just interesting that they're essentially from the same source. So I'm using dump1090 here. And what that's going to do for us is read these messages from a software-defined radio. And it's going to make them available on a port in a format that we'll need to decode. And then we'll write some software. I'm going to write that in Node.js. And we can then do something with that. So to have this software working, we need to compile it. It's a C program, so I've gone off and done that ahead of time, so we don't have to watch compiling C stuff on a live stream. But basically, you get this, you compile it, and then you get an executable that you can run. It needs to work with a there we go, a software-defined radio type product. I happen to have this one. There's others available. There's a company called, I think, SDL or something that is quite popular. But basically, you want something that understands these ADSB messages. And this is one of those things. There's a few available. And it looks like this. It's a USB stick. It's currently plugged into the laptop, so I'm not going to pull it out and show it. And on the other end, it's got an aerial socket. And we need to plug an aerial into that so we can see stuff, because this is essentially line of sight radio. It's going to only see what the aerial can see. So these are kind of as good as the radio aerial. I've got a radio aerial. I've got one of these. It came off of eBay. It's quite long and it has the right connector on the end. So it just plugs straight into that USB thing. And if I temporarily remove this, you can probably see it along with some other stuff. So there it is in the window over there. It's just literally hanging from the curtain pole. So we have a radio aerial and we have our software-defined radio plugged in. And back to the software side of the house, I've got this dump1090 package. I'm running that at the moment. And the way I'm running it is in a sort of interactive way. And basically, we're going to get what data it can see at a given time. So right now, there doesn't look to be much going out or going around there at the moment. We've got some information about some flights. So one just disappeared. And what it's going to do is show a sort of amalgamation of information it's got from messages from these flights. So at some point, we'll have like the latitude, longitude, the heading, the speed, and so on. they're all disappearing at the minute. So fun with live demos. And once it's got this, the other interface that it gives us that's built into dump 1090 is this map. So if we could see any flights at this point in time, which of course they've all disappeared off my radio for the moment, we would be able to plot these and it would do that for us. So we'd see that and we could click on it and we get some really basic information about the flight. So that's kind of where we're going with our data source. This is going to be sort of a long-term gathering thing because we have to pull data as it passes by us. And let's see what we can do. So that's dump 1090. That's dump 1090 running in the background. This in itself isn't that useful to us for writing software. So what we need is something that can decode these messages. And there's a Node module out there called Node SBS1. It basically listens to things that dump 1090 puts out, and it's going to decode that into Node messages that mean something to us. So we don't need to worry about the format. It's going to handle all of that for us. And essentially, we are going to receive messages that look like this. So they have information about the flight. And the thing that we really, really want is some sort of flight ID so that we can put that into FlightAware later and see what happens. So it looks like we're starting to pick up a flight again here. Maybe. We'll see. You'll see that these fields fill out over time. So what we need to do is read these messages, do something with the data, and then when we get some data that's interesting, we want to trigger our front end. So I think the best way of demonstrating this is going to be through a bit of a diagram. So we like an iPad diagram on this channel, and let's see what we can do here. So what we've got over, let's make it over here somewhere, is we've got a terrible drawing of an aircraft coming at us, and the aircraft is broadcasting stuff. And then we've got an aerial, and we've got a USB stick, and we'll have a component here that we'll call, I don't know, the receiver that we need to write in software. So this will receive messages out of thin air, and it will decode those messages, and we're going to write that in Node. And then once we've received those messages and got information about the flight, we need to store that somewhere in a data store. So we'll use, this is after all a Redis channel. So in Red, we'll use Redis, and we are going to store the data in Redis on a per flight basis. Then what we need to do is augment that data with something else. So we will have some sort of a queuing structure here. And whenever we see new flights and we've got enough data to call FlightAware, we'll go ahead and put an entry in the queue to call FlightAware and say, hey, FlightAware, what have you got for us? And we will have a component out here that will basically get flight details. And that's going to go and talk to FlightAware API, get a response back, and augment that data in Redis. And it's going to work off of that queue. So it's going to pull things off of the queue, and its job is just to get the flight details. So hopefully we'll have some sort of good separation between components there. We'll have components only dealing with getting the data and putting it in Redis, and it doesn't really care what happens after that. It knows about an aerial. And we'll have a component that only knows about jobs that need doing with FlightAware. So get me the data for this flight ID and put the results in Redis. And those two things will be sort of separate from each other. And then we'll need to build some sort of mechanism that we can think about later that has our display, and it can show information about whatever the nearest interesting flight is. And we'll sort of leave how to do that as an open question for now. So once we've got all of this information, we need something that says, oh, there's a flight that looks interesting. It's like an interesting aircraft type or something. And it's going over right now. So update the display. So that's roughly what we're going to try and build over probably a number of live streams, because it's a reasonably ambitious project. And also I'm going to have to do some stuff in between streams because of the nature of the data source. I'm also going to live stream at different times of day for this because let's just get rid of this. As you can see right now, it's fairly quiet out here. We're still not really getting anything much. There's this flight GAWFB. If I come over here, you'll see that this is turned up on here. We saw it at 2,500 feet, but we don't have a location for it yet, which is why it's not on the map. And using the dump 1090 interface, I can click on this and I can click on the flight aware tab, and it's just going to bring up a flight aware URL with this flight's information. So what can we see out of this? Not a lot. This has come from our local, like, general aviation airports, and not the one that commercial flights come from. And it's currently flying somewhere near us. So not that interesting yet. And it's actually disappeared off of dump 1090. So the other thing with this is I'm going to see things my radio can see. So I'm roughly here in Nottingham, which, if we want to zoom out a bit, is we're kind of in the middle of England. So you can see where we are. So we can expect to see things in this sort of area here, perhaps. And actually, we've got something that's turned up here. Look, AFR 066. That's probably going to be an Air France flight. So let's take a look at this. Yeah, it's an Air France flight. So this is more representative of the sort of data I want to be able to get from FlightAware's API. So this is a commercial aviation flight. It's going from Paris Charles de Gaulle to Los Angeles, and it's currently passing over us at 30,000 feet. So FlightAware's map is more detailed because they get inputs from way more of these radios. They're not just relying on my one little aerial, but I want to use data that we've got. So for now, for this flight, we've got an altitude of 30,000 feet. So we're receiving stuff from that plane. We haven't had a message that contains the location yet, and we haven't got an airspeed for it. But we've had 57 messages from that flight so far come in. So it's quite chatty. And what you can see here is that that's the only flight that we're tracking at the minute with dump 1090. That's what it can see on my radio aerial. So now we've got this up and running, what we need to do is start receiving these messages, and each message contains like a bit of the puzzle. So we're going to have to store values from lots and lots of them in order to get anything useful. And what we can do is I'll leave this running and I'll leave this up here. We need to use this SBS1 module. I'm going to build something really, really basic in Node that just dumps out these messages, and then we can start to look at what we've got and what we can do with them. So I need a new shell window. I'm going to start a new Node project. So let's do cd source projects, cd to my project directory, and let's do aircraft tracking stream. We'll make a new project. And we'll just npm init that because we're going to use a Node project. And yeah, this will all be fine for now. And we'll say, yeah, MIT license. Okay, so now we've got a project here. I've actually gone and done something that I probably shouldn't have. I said I was going to make components for this. So this is going to be the receiver component. So let's do, and then move that package.json into receiver. So now we've got a bit of a tidier project because we know we're going to need some other components later, like for getting things from FlightAware. So cd receiver should have a package.json. We'll create a file called index.js. And no, let's not do that. I don't like calling things index.js when we have multiple components, because when you've got them open in an editor, every file ends up being called index.js and you don't know which one is which. So what I'm going to do actually is do touch receiver.js, and that'll probably do. And then I'm going to need this SBS1 here, so we're just going to install that. Let's do npm install SBS1, and off it goes. So we've got some moderate security vulnerabilities, but we'll not worry about those. So we've now got our package.json and our package lock.json. So let's start up VS Code and take a look at what we've got. So in here in receiver.js, it's completely blank, as you'd expect. In package.json, let's make a couple of changes. Receiver.js, and let's put a start. Oops. Something like that. So let's do that, and let's do something else that I always forget until it errors. So we'll call this a module. So I can use import syntax and top level await and all of that stuff. So that should be okay. So we'll do that, and now we've got a blank receiver.js here. So we need to figure out how to use this. So here's some old school code. We don't need to parse stuff. We need it to listen to dump 1090, which is outputting this stuff on a port. So let's see how we do that. Okay, so here we go. Connect to a server on localhost 30,000 that is sending messages. I know dump 1090 does this, so we should be able to do that. And we can pass in an options object. Okay, so we need to do something like this, and then we need a client.onMessage callback. So let's try this, and let's do something like that. And let's see if we can connect to the local host. So what we need to do is let's create an SBS1 client equals what do we want? SBS1 dot create client. There we go. And we want some options for that. And our options are going to be a host and a port. So we want host is going to be 127.0.0.1 and port is going to be 30.0.0.3. So hopefully that'll be all right. And then we need something that looks a bit like this on message callback. So let's do something like SBS1 client.on message, and then we need a message. And for now, we can just console.log whatever we got, I think. And we probably need to do something to start this, do we? Or do we? I don't know. Let's have a quick look. Do we need to do anything to start it? No, I don't think we do. So maybe that's it. So let's see what's going on. Over here, we've got, ooh, look, we've got some flight data. We've got RYR, that's a Ryanair. They're a like low-cost carrier around here. FPY, no idea what that is. But look, we've got a lat long for that now. So we've got a flight that is on our dump 1090 map. There we go. FPY1A. I have no idea what that is. So let's ask flight aware. It is off to Iceland. Okay, so it's come from London Stansted and it's off to Iceland. And flight aware can tell us all of this stuff about this. So it's an A320 Neo, so that's like the newer version of the A320 with bigger engines, and they can tell us who it belongs to and all of that stuff. So we can get this from their API. And this is exactly the sort of stuff we want to track. But first steps first, we need to actually read the radio messages. So going back to here, dump 1090 has got that port 30003 open, and hopefully when we take our code here and do something with it, so let's see what happens. So connected, oh, and we get messages. Okay, so we are getting messages, and as you can see, the radio is quite chatty. So every time this this goes ahead and receives a message, it's passing it on to us, and it's raising an event in our node code. So now we've got dump 1090 talking to our node code through this SBS1 decoder thing. And we've got lots and lots of messages going on here. You can see for this one flight here, we've got 1,600 something coming already. So this is really, really quite busy. There's a lot happening. Let's just pause that for a moment. So there's a lot happening here, and it's going to take, we're going to need to make some sense of it, because as I was saying earlier, you don't get like a singular message that says, hi, I'm flight, whatever this one is, FPY1A, and my location is this, and my height is this, and my speed is this. You don't get all of that information in a singular message from the radio. So we're going to have to build that up over time. So what I want to do with that is use Redis to store that information, and basically using the flight ID here. I think it's the flight ID we want. Let's see. Oh, we've got quite a few now. Look, we've got a DAL221. That's going to be Delta. Let's see what's on our map here. So I can click on DAL221. There it is. DAL221, which is a Delta flight also from Paris to Salt Lake City. So we've got a few things coming along here. So we want to look at some of these fields here, see what we've got. So I think we want this, no, we don't want the hex ID, we want the flight ID. So let's just run this again and see if we can find some of those flights. So what we can see here is 4CC528, that maps to this FPY. That was our flight to Iceland. And as you can see, not every message has got all of the information in. So we don't have the flight ID FPY1A in there in this message. And that's what we need to make a flight aware call. So what we're going to need to do is start storing all of this data in Redis and then take a look at it over time. So this is a flat map of name value pairs, and there's some of these that we're going to be interested in. And one of the ways we can store things in Redis is what's called a hash, which is a flat map of name value pairs at a given Redis key. So we can start to track these flights, and we can see what's going on with them, and we can start to build up information over time. And then when we have enough information, we can trigger a call to flight aware and say, go get us the rest of the information about what this aircraft's actually doing passing by my house right now. So we can do that. And let me just, check the comments. Okay, we're all good. We can do that, and let's see how that goes. But first, what we're going to need to do is actually get a Redis database. So let us do that. So we're going to get a Redis database, and the best way of doing that is just get one out of the cloud. So we're going to go to redis.com. You can go to redis.com/try free, get started with Redis Cloud for free. That should be ample for what we need here. What you get here is 30 megs worth of Redis with, well, you get Redis stack. So you get all of the search and JSON capabilities and extra probabilistic data structures and all that stuff. We might use some of that later on, but I've obviously got an account already, so I will not sign up. I will log into the console here and I will create a database so we can use that. So I've got what's called a subscription here. So we pick a subscription when we create a Redis account, and that basically says, where do I want to put my databases? So Redis in the cloud here through redis.com is available in different clouds. So depending on where you want things to live, where you want to put your software, because with Redis you want the software and the database close, so there's minimal network latency between them. We're not going to worry about that for this project. I'm just going to run the code on my laptop and we'll connect to Redis in the cloud. But I've gone with US East 1 in AWS. I could have picked Azure, I could have picked Google Cloud, I could have picked other regions. So I'm going to create a new database in there. I want Redis stack because I want all the features. So we'll leave that. And we're going to call it things on Thursdays. And the rest of this looks fine to me. So I'm just going to click activate database and you'll see there's a little pending there. So what's going to happen is I'm going to get some information about my database that I'm going to need to connect to it. And when it's built that database in hopefully a moment, we'll get that information. So there we go. So we got green, we're active, got something. I've now got a host name and a port here. And I'm going to have a username and a password down there. We're going to need the password to connect. And I'm going to use a tool called Redis Insight that you'll see us using a lot on stream. So you can get a free copy of this as well. And Redis Insight here supports connecting to multiple Redis databases. So I've got a few that I'm using already. And I'm going to add this new one. So what we're going to do is paste that in, and it understands Redis in the cloud format. So it's already done the host, and we're going to call this, let's call it things on Thursdays here in Redis Insight. And we don't need a username, or we could use default. We do need a password. So I'm just going to take that off the screen a minute, and I am going to grab the password from the redis.com interface. So I've copied that. I'm going to bring this down here to make it very sure. Right, pasted that password in, and we've now got a new database that's been added successfully. So here in Redis Insight, we've now got that new database. I can click on it, and what we've got here is a key browser, and if we were to put some data in the database, we would be able to see it. This is literally a stick and new database. We don't have that information, so there's nothing in it. We just create a blank one. So what I can do is use the CLI here and just demonstrate the sort of data structure that we want to create. So I could do this graphically as well, but I'm going to do it with the CLI. So we want to use a command called hset. So I want to use a hash in Redis, which is a flat map of name value pairs, and that lives as a key. So we can call it something like flight : and then some ID. So we'll just literally call it some ID. We'll need an ID for our flights. I'm using sort of meaningful key names here. So flight, because it's a flight, and then : and the ID. And that's how we're going to refer to these. And then in here, we put name value pairs. So we might put lat and then long and then just arbitrary data. And then something like, I don't know, what else have we got in those messages? Altitude, let's say that's at 27,000. And when I hit return there, you'll see I get 3 back. So Redis is telling me it's put 3 things in that hash. When I refresh here and I click here, I've now got my data here. So we stored this in Redis, and we can use this as key as like a scratch pad for everything we know about this flight. If I want to get that back, I can just do hgetall flight some ID, and it'll get that back. Or I can do hmget flight some ID and just list out the fields I want. So if I just wanted latitude and altitude for some reason, I get those 2 back. So that's the data structure we're going to use to store this information in. And let's get rid of that. There we go. So, and close that. So we're back to having an empty database now. So what we need to do is connect our node code to this database and then start storing some of this information in here. So how do we connect to Redis from a node application? Let's bring the browser back here. We want another package here on npm, and I'll actually start a new tab for this. So if we go to npm and we put in the most generic search term for Redis, we get an exact match on something called Redis, which is Node Redis. It's a Redis client for Redis and Redis Stack, and it supports all of these functionalities in Redis Stack. So we're going to use this one. It's quite a popular client. There's another client called IO Redis you could use as well. So use that if you want to, but we're going to use this partly because it's got this support for the extra Redis Stack features that's kind of a bit more baked in and native to this client. So I'm going to install that into our project here. So I'm in the receiver folder. Just make sure. npm install Redis. Let's have a Redis client installed, and we are good. Now, I, like most people, am a pretty lazy developer. So I happen to know that if I go to GitHub over here, there's lots of examples of how to use this client. So we're going to go ahead and just take one of those. Let's scroll down. And here we go. There's a template here that just shows us how to connect to Redis and how to quit. So we kind of need these things, and we will put those into our code here. So we're currently using SBS1. We also need import create client from, that's done it for us, clever. So import create client from Redis, and we need to create a Redis client. So we'll call that Redis client so we know which thing we're talking about. And we need create client. And this by default will create a client that talks to Redis on the local machine. And Redis has like a standard port of 6379. We could connect to that if we were running Redis locally. But we're not. We're running Redis remotely. So we need to pass in a config here. And one of the ways we can specify a Redis connection is, I think, a URL. I think we do it like this. So let's have a look. If in doubt, read the docs. So here we go. Basic example. Here we go. This is what we want, something like this. So we can connect to a Redis instance, and we need to provide a URL that is redis://user:password at host:/port. So what we'll do is here we'll do something like URL equals, and we'll say process.m.redis URL, and we'll give it like a default of Redis. Default is the kind of default username. Actually, no, we don't even need that. Redis:// something like that. We can just use the host name. So 127.0.0.16379. But if you don't find a process M Redis URL, try and connect locally. I know that I've got a process M Redis URL that I need to set because we're going to use that cloud database. So what I'm going to do is really quickly set that. So let's do that off screen and do export Redis URL equals this : / and I'm going to need to borrow some information from the Redis Cloud Console here. I'm going to want this host name. Oops, sorry. I'm going to want the password first. Let's do that. And now I'm going to want the host name and the port. Okay, so we've done that. We bring this back, and we've got that connected. Well, we haven't got it connected yet. We've just set it up. So back to our code. So we should have something there, and URL should be Redis URL. Hopefully that works. Now back to our Node Redis example. So we want to await client connect, and then we can do stuff with Redis. So let's wait. We called it Redis client. Await Redis client.connect. And now we should hopefully have a Redis connection, and we can then do something with it. So for every message we get here, we want to store something in the data store. So we could just store absolutely everything, or we could store certain fields, but I don't think we necessarily know what we need yet. So let's maybe try and store absolutely everything. So the way that works with Node Redis is there's functions that correspond to Redis commands. So I am going to do, let's see, let's make a key name for this. Flight key equals, we're going to call it flight : and then we need some information from the message. So let's go and look at what we can use for a key. And SPS1 here has its schema for all the messages. So let's see, we've got some IDs here, but I don't think they all turn up in each of these message types. So we want one that always shows up. So let's go back to our terminal here. Of course, we've got no flights visible at the moment. So let's, oh, here we go. Just when you need them, some flights turn up. So let's see what we get. So we're going to need to run this code again and see what the message looks like. So we'll not worry about any more code for a second here. Let's just run this. Oops. Well, apparently that's invalid syntax. Didn't know that. Okay. Right. So here's our messages again, and let's just see what we've got here. So we've got an aircraft ID. We've got hex ident. I think that's probably going to be the one that we want. Yeah, so let's use the hex ident as part of the key. So we'll basically do message dot hex underscore ident. Something like that. That's our key. And then hopefully we should just be able to do Redis client dot h. What do I want here? I want to be able to set everything and basically store all of the fields, because we just don't know what is going to happen yet. So I'm just going to check on our chat system over here. And yeah, let's just use the hset command. So we're going to do redis.hset. We're going to set a hash. The cool thing about working with Redis is if this hash doesn't exist yet, we don't have to dimension or create it or write if-else code to check that. We just write to it. So we're going to do flight key, and then we are going to set, we need field values. So we are basically going to want to, I think we can just do something like that, actually. Oh. Well, this is on there. Okay. So let's see if we can just set that and see if this falls flat on its face or does something. Hey, it fell flat on its face. Okay. Invalid argument type. Oh, that's in the Redis encoder. Oh, I see. Okay, so we've got some nulls in there. So we can't just write everything in there because that's not going to work. So we're going to have to pull out things that we need. So let's see what we've got in the message that we think is useful. So let's start with some basics. So instead of this, we'll create a message data object. And let's see if we can write the message data object to it. And what we need is flight, let's do hex, ident, message.hex, ident, and let's put something else in there for a moment. It might be useful to have transmission to, I don't know, no, because that's going to get overwritten. So let's store aircraft ID as well, for example. Let's got aircraft ID, and let's see if we can save those. There we go. So now we've got messages coming in, and we're storing values in hashes in Redis. So we can start to maybe sort of make sense of some of this stuff. But we don't have much data in there at the moment. So if I go here, I can turn on this auto refresh in Insight, and it will refresh the keys. So we've got a couple of flights that we're tracking here, 40799B, AO554DB. And if we click on those, you can see we've got our values. So we're starting to store stuff in the database here. And the third flight turned up now as well. So what we need to do is figure out what information we want to store from these. And what we want to do is store some values when they're non-null. So you see these lat long values, they keep like being null and then not null and null and then not null. So we can add those in because we need those. And let's store those. So what we need to do then is do something like only store them when we've got them as well. So what we need to do is something like if message.lat, I guess. Then we want to do message data.lat equals message.lat, something like that. And similarly for if message.long, message data.long equals message.long. And the reason we want to do it this way is to make sure that when we receive this information, we just kind of store the last version of it that we got. So not all of these messages over here have this information in. So we don't want to overwrite them with null because a different type of message came in from that flight that doesn't contain that data. So let's see if that gets us anything useful. So off it goes. got to wait for one with lat and long. There's one turned up, there's a couple. So we'll see if we look around here, if we've got any of these with lat and long in them yet. Oh, we've got a latitude value there. So it seems like we don't always get the pair. So let's see, we've got a latitude, or maybe I've made a coding error. So got a latitude on that one. So why are we not getting longitudes? Message.long, message data.long. Oh, because I've put LNG and it's LON. Wrong abbreviation. Message.long, right. Let's do that. And while we're at it, let's put in altitude and ground. Well, we don't need ground speed. If message.altitude message data.altitude equals message.altitude. Okay. So let's restart it. And off it goes, and hopefully it's doing things. And if we go here, we can actually turn on the refresh over here as well, right? So if this flight got some more information, there we go, it'll update it. So this one's got a latitude, longitude, and an altitude, which is good because now we can start to do something useful with it. But what we need as well is, so we've got this A054DB identity. We go look on the dump 1090 map, we can see there's an A054DB 120. But what we really need is this flight M120MX information. That's what's going to allow us to talk to FlightAware and do something useful. So what I want to do is grab that and figure out what field that's in. So it might be flight_ID. Let's see if we've got any data scrolling by that would tell us that. We've got 111111 there. So flight ID seems to come out as 111111 a lot. Is it call sign? Let's see. Call sign, 8-character flight ID or call sign. Yeah, that's probably what we want, isn't it? So we want to add a call sign tab to this, or a call sign thing. So if message.callsign call sign, no, it's all okay. Call sign message data dot call sign equals message dot call sign. And let's have a look at this. Are we getting any values that we can check out here? Because I've got an idea that when we saw one of these that wasn't null, it actually had like some spaces or something in it. Not seeing one at the minute. Okay, so what we'll do is when we see one, we'll actually log it and we'll take a look at what's in there. Hello, it seems like we temporarily lost the internet there. So sorry about that. What I'm going to do is reshare my desktop and see if we can pick this up. There we go. So hopefully we're back in the room now. I don't know where we got lost there. I just got this inkling that something had gone wrong. We use some software called StreamYard that's normally really good, and it disconnected, which might have been my internet connection, but that's strange if so. So we were basically looking at what keys we could use, and we wanted to use this call sign field that you see scrolling by here in these messages, but I was suspecting it may or may not have some sort of leading spaces or trailing spaces on it. So I was looking into whether we could add that and whether we needed to trim it or not. And I put this code in here and started to run it. And we haven't looked at what turns up in Redis yet, but let's do that now. So as you can see, we've started to get more flights here, and we've got a call sign there. So yeah, you see that's got like a space or some spaces on the end. So BAW11M, that's a British Airways flight. That is good information. We want that, but we want to trim it. So we want to do message.callsign.trim. And let's clean that out and stop that. And okay, so we've got all of these flights in the database here. And what I'm going to do is something quite drastic for the moment. I'm going to do flush db, empty it out, and you'll see we don't have anything now. So we're going to start from scratch with a little bit more reliable data. So off we go. We're putting data into the database. We've got these flights building up here. If I click on one, you'll see, oh, here we go. We've got BAW11M is back again. So we've now got some useful information in the database for our flight. So what we need to do now is go ahead and figure out what we want to do with this information. And also, do we want anything else? And we've also got a slight problem at the minute of we're building up information about every flight we've ever seen. And that's okay, but our sort of universe of flights is really the things that are within the radio's visibility. So we've got these flights here that we can see going on at the minute. If I pick on BAW11M, you'll see that it's just here. It's just passing. I'm over here in Nottingham somewhere. It's passing Derby, which is a nearby city. If we go to flight aware for that, you'll see that BAW11M is, well, it's off to San Francisco. So that's off to San Francisco, and we can see it is the en route flight today is a B789. So it's the middle size Dreamliner. Looks like this one varies a bit. Tomorrow it looks like it's going to be the smaller one, and yesterday it was the smaller one, and so on. But this is a Dreamliner. It's off to San Francisco. Our radio doesn't know any of that information because the plane doesn't broadcast it. So we need this ID, BAW11M, which we're now capturing. And then we need to talk to FlightAware and do something with that. So I think we've about got most of the things we need in our receiver component to get enough information. You know, there's some things that we're not too worried about, like we don't really care about the speed or what have you. But there are a couple more things that I want to put in there that I think will be useful. And we also need to do a bit of data management. So as I was saying, in Redis here, we're going to be tracking every flight that the radio has ever seen while this was running. And what we're not going to see is that these flights stop updating because the radio stops seeing them. You know, that flight to San Francisco, it's going to go off on its merry way to San Francisco. It is not going to suddenly say to our radio, bye, I'm about to go out of your range. You know, it doesn't work like that. So what we need to do is track these flights for a distinct amount of time and then drop them. So this is where Redis as a cache is very handy. So anything that's a Redis key, like all of these hashes, we can set a time to live on there. And after that time to live, it will basically mark it as invalid and it will disappear. So if every time we receive a new message from this flight, we go ahead and update this hash. If we also update the time to live on that flight, then we're kind of like saying, okay, I've received the message, it's still passing by me. If I've not received one in some period of time, let's assume that that flight's gone away. It's out of the range of our radio now. So we need to set an expiry time. So what we need to do is down here, have a to-do, update expiry time. And what we need to do as well, I think will be useful, because at some point we're going to want to know what the most recently active flights were. So yeah, if we're going to build a display on some little front end, that is going to show us like a couple of flights that are passing by right now, we're potentially going to sort these hashes in future by the time that they were last updated. So what we need to do is basically set a last updated field. So we can do that up here because we're always going to set it. So we'll say last updated. And we want that to be like the timestamp for now. So let me try and remember, because I can never remember how timestamps work in Node. So let's try it and see. So if we do this, and I think something like, I don't know why I'm doing that even. I think I can just do date.now. Yeah, that looks great. So that gives us a timestamp. So we'll use that. And let's come out of here. So we're going to say date.now is our last updated. So we want to put a last updated field on there. So let's just try that out and make sure it's working. But hopefully every time we get one of those, we now are going to be telling Redis that we saw something. So I don't know which flights. You see, we might have some flights that have already passed us by. There we go. So here's one. It's got a last updated timestamp now. And we should be able to flush the database, and then everything in there is going to have that. So flush DB. Spot again. So here's our active flights now. They're coming in pretty fast now. Things are picking up. DAL81, that's a Delta flight. Tom 824, that's a Thomson, they're a holiday carrier. And QTR 76, that's probably a Qatar Airlines flight. So we've got a few coming in now, but we've still got this problem of when they go away, we're not going to know that. So what we need to do is also down here, we need to do Redis client dot expire. And we expire at a key level. So we want to expire that flight, and we want to expire it after a certain number of seconds. So we just need to basically pick a number for how long do we want to keep these. So we'll call that flight retention period, and we'll define that somewhere. And let's say we've done that. So now we need a flight retention period equals, and it's seconds, so 60 seconds in a minute, and let's say 30 minutes, something like that. So we're going to, well, okay, let's think about this. Let's just zoom out a minute, see where some of these flights that we've got are. So this one up here, the Delta one, that's almost in Sheffield already. So that's like about 40 or so miles from me. So that's quite a bit of range. And it may be that these actually, you know, if they sort of fly from down south and they pass over us, we may be getting that information for quite some time. So let's say we want to do, let's do an hour. We can always change it. So let's try that. And we're going to say expire after an hour. And then what I need to do is stop this and restart it. And let's flush the database first as well, so that we can see the effect that this change has. So flush DB, okay, flush the database, nothing in the database, and let's start again. So npm start, off we go. We are stuffing things into Redis now, and we've got a flight here, and you can see here we get over here, we've got 59 minutes an hour. And if I pick on one of these, it's got a TTL in seconds. And if we refresh this, you'll see that's counting down. So what's going to happen now is if we don't get any information from this flight within the hour, then it's just going to expire out of our cache, and we're not going to consider it sort of a flight that we're interested in anymore. So what we've got here, I think, is pretty much the entirety of our data receiver. It's pretty simple code-wise. So it's what? It's like 46 lines of code, including some blanks. And let's just recap. So what we're doing here is we're running dump 1090. That reads data from the plane, from the aerial that we've got plugged into this computer through a decoder dongle that's plugged in. Dump 1090 deals with that. It's then publishing that data in a known format on a port that something called SBS1 here is a decoder for. So our SBS1 client is decoding those messages. Every time it gets a message, it just gives us a nice flat map of name value pairs. And then we're just logging that out. We're creating a key for Redis, and we are updating that with the last time that we saw something, the aircraft ID and the hex identity. And those are kind of like guaranteed items in the message. And this one we're generating locally. And then we're doing some tests for, does the message contain any of these fields that we're interested in? If it does, we're adding those to the object that we want to store in Redis. And then we're just storing it as a hash, and we're setting the expiry time. So if the flight disappears from our field of vision or our aerial's reception area, like it disappeared off of there, and we don't hear anything from it, then after an hour, that data will be removed from Redis. So we're not building that up anymore. So we can see here, this one's got 3548, and what you'll see is periodically these will reset to the hour when we get another message for that flight. So 407 CB3 here just reset to an hour. There we go. So that one's chatting to us at the moment. We can still see it. And what we should see if we update this is that if nothing else changes, the timestamp field changes. So we've started to capture this information about the flight. And what we then need to do, and we'll do that in our next stream, is look at the flight aware API. And we need to be able to use this value here. So RUK6TF, let's just copy that. And we need to essentially do what happens when we go to this URL. So if we put in a flight identifier here, you can see this is a Ryanair flight. It's going from Poland to Manchester in the UK. You can see the whole flight track, beyond what our radio could track, because FlightAware's got that data. But what we're really interested in is this sort of information. So it's a 737-800. We can get the actual registration from the FlightAware API. This public interface doesn't show that. It says upgrade account, but I've got an API key. We can pull that information, and we can put that in Redis. And then from there, we can start to build up a picture of, is this flight interesting? If it is interesting, we can notify our front end and say, hey, display this interesting flight on the notification front end that we're going to build. So quite a lot of stuff going there. And we seem to have had a small technical issue during this live stream, but hopefully you stuck with us during the the period there. What I'll do is I will see if we can trim that in YouTube so that when we look at this video, or when you come back to look at this video in YouTube, it will be there minus the gap where it seems like my internet failed or something weird happened. And the other thing I'll do is I will put this code into a GitHub repo, and I will probably tidy this up so that these values are also in a secret like this, so that we're making things a bit more configurable, and maybe do the flight retention period as well. But I'll tidy it up a little bit, put it in a GitHub, and then what we're going to do on the next live stream is a couple of things. We want to have a mechanism so that when we have enough of this data in Redis, so when we know that a flight has got the things that we need to track it with FlightAware, which is basically the call sign, but we also want to know that we've got a latitude and a longitude, so we've got a position, then I want to know that we've got the call sign. I want to put this into like a job queue in Redis, and I want to build a component that says, hey, go talk to FlightAware's API and basically feed it a call sign. So this Ryanair flight RUK60F, for example, feed it that, and then get all of the good data that FlightAware's got from that, store it in Redis in this flights object, and remember that we got that, so that if we receive another message from this flight and we're asked to go get the data from FlightAware again, we don't need to, because we've already got that data. So we're kind of using a sort of memo caching system to remember we got that data. And the reason why we are going to do that is twofold. We're being nice to third-party APIs. We don't want to call FlightAware's API too much. And the other reason why we don't want to do this is that the FlightAware API here is a billable API. So every time we call it, something comes off of our allocation. We get so many free, and then after that, we have to start paying for them. So we will need to start paying for them, and we want to avoid that a little bit where possible. I don't mind paying for good data, but what we don't want to do is every few seconds say to it, hey, tell me what type of plane is operating RUK60F today, because we knew that 10 seconds ago. We know it's a 737-800. We don't need to keep asking for that information. So we're going to do that. And on the next live stream, I'll do that. That live stream will be at a date that I'm not entirely sure of right now, because I have got some scheduling issues, but I'm hoping to go live again within the next week and continue with the momentum on this project. So the best thing to do would be watch out at developer.redis.com page here, and what you'll see here is our upcoming schedule, and I'll put the URL down the bottom there. So you'll notice we put in upcoming events anybody that's about to stream. So at the minute, myself, Justin, and Savannah are streaming. And then over here in past events, you will see links to all of our things that we've done before. So if you want to check out my last video on Redis streams, just click here. It'll take you to the YouTube. The other way that you can find out when we've done something is go subscribe on to our Twitch channel. So we have Twitch. Subscribe and hit notify, and you'll get told when we're going live. And similarly for YouTube, everything lives on YouTube long term afterwards. So you will be able to find us there. And that was about it for today. The only other thing that I've got to plug is Redis Discord, as always. So another way of keeping in touch with us between live streams, or if you've got questions or suggestions, or if you're just playing with something cool yourself that you want to share, we love to see your projects. Go check out discord.gg/Redis. Join us on there. Finally, the thing that I haven't shown or mentioned in this stream yet is I said I wanted to build a sort of notifying interface for, okay, well, what what interesting flight is passing by. We might actually eventually finally use the big bus sign that's behind me. That's an electromagnetic flip disk sign that we can display information on. But I've got a couple of devices here that I was thinking of looking at. So this one is a Seed Studio. It's called a WIO terminal. It's got buttons, it's got internet, it's got connectors on the back for Raspberry Pi things, more buttons, and obviously a screen. And this one here is a Pimeroni product, and it has got an LCD screen on the front, so we can do like old school calculator type graphics and things. And you basically plug in your Raspberry Pi Pico W into the back. Well, Pico or Pico W. W gives you the Wi-Fi, which we're going to need to talk to a service. And one of these speaks, well, they both speak MicroPython and C. So that's probably where we're going to be building an interface. But we'll need to do a few things first. We need to get the flight-aware data to augment what our radio can see. And then we need to build some sort of search schema over those hashes in Redis to basically determine, find me a flight that is interesting. So it's an aircraft type that I've deemed interesting, or an airline that I'm interested in that's not the normal thing that goes past. And find the most recent updated flights out of our list. So for that, we'll be using the Redis search capability of Redis Stack. And again, you can go get a free database. It's available in the cloud. So you saw me do that earlier. Just go to redis.com/try-free. You also saw me use Redis Insight. You can download that from here. Entirely optional, but it's kind of a nice graphical tool. And it does let us look at data in real time. So you'll see that when I was using it, and let's just bring it back a second, because it is kind of cool that during this stream, we've built something that's like tracking this many flights, and you can see some of them have maybe dropped off our radar now. So this one over here, it's been, well, it's got 49 minutes worth of time left to live. So 60 minus 49 is what, 11, 12 now. We last heard from it 12 minutes ago. And it looks like we never got a lot long for that, but we got a call sign. It's an EasyJet flight. So we can start to see that we built something that is tracking data that we're pulling out of the air. It is doing a reasonable job of getting information about it. And getting a lot of these that don't have positions at the minute as well. And that's one that does. And then once we know the position of it, we can go ahead and figure out whether we're interested in it and go spend the money on a flight aware call to get more data. So hopefully that's something we can do next time. Hopefully next time is in the very near future. I can't commit to a specific date or time at the moment, but I will let you know via all the usual channels. And yeah, that was it. If you are interested in learning more about Redis, I always plug Redis University. So go check out Redis University. It's our online free courses. And if you have a more specific question, or you want to do something in sort of semi-real time with the community, discord.gg/Redis is a good way of reaching us in the developer relations team, also people in product at Redis, and more importantly, a wider community of all sorts of developers that build all sorts of things. So it's coming up for lunchtime here in the UK. I will leave you for the rest of your day, and see you next time. Thanks, everybody. Bye.